Today we have a chapter which name is rectilinear motion. As you can see, there are some topics which are mentioned over here. We will explore all the topics in details as much as we can do. Rectilinear motion. Let's start without wasting time because I don't want to waste time anyhow. Uh, this is a subject of physics. Some numericals will come, some formulas will come, some main points will come. Remember, unnecessary points will not be discussed with you. Whatever will be important, we will look at those important topics. Now tell me, what is the meaning of a rectilinear motion? Can you explain? What is the meaning of rectilinear motion? Look, rectilinear is equal to linear. Both are equal. Okay, both equal. Only one point will tell you difference between linear and rectilinear. Linear says that any object is moving in a straight line. Same it happens with rectilinear. Okay, but remember, there can be a lot of objects, and those a lot of objects. If those objects are moving in a straight, remember, okay, if two or more objects are moving in a straight direction, then this type of motion will be known as rectilinear, and that is what we are going to explore in details, whatever we can cover. I want to start with dimension. First, one dimension, two dimension, three dimension. It will be very important to understand all this dimension because it will give you importance of motion. What do you think about one dimension? I want to know from you. What do you think about this dimension? If you know, then okay. People who don't know, I am explaining it. Remember, here if we take one dimension, we are saying that a object is moving in one axis. It can be x-axis, it can be y-axis. But remember, only one axis. Okay, only one axis. Because here we are talking about one dimension, so one axis. If a object, you can see this is object. If this object, it is moving like that. It is not going upward, it is not going downward. That's why we can say this is a one dimension motion. Okay, this object is one dimension because it is moving in x-axis. This y-axis, what about this y-axis? If this object is going downward and it is not moving this side and this side, that's why we will say it can go upward as well. But remember, it is only moving. This object is only moving in one axis, in one straight direction. That's why we are saying this is a one dimension. Clear? This is a one dimension. Now, what about a two dimension? Two axis. We will take two axis. Okay, two axis, x comma y. X comma y. You can take a object so that we can understand all this dimension. Here we are talking about a two dimension. Simple definition. There is a simple definition of a two dimension. It is not difficult to understand it. An object. If an object is moving in two axes, remember in two axes, not in one axis. What I am saying? I am saying if any kind of object is moving in two axes. I am talking. Let's visualize it. I am drawing a figure like that. Now you are already familiar that this is a y-axis and this is a x-axis. You know this one. Main point is over here. We are taking a object. Okay, an object. For example, this particles. Let's say. This point is known as origin. 1 2 3 4 5. 1 2 3 4 5. 1 2 3 4 5. Okay. Now what is happening over here? There is a particle which is present here, and there are two axes. Can you tell me? Could you tell me what is happening over here? We are talking about two dimension. Okay. Remember. Now X and Y will show a amazing thing. I will show you. Remember, if A object is moving in one axis, then at the same time another axis, at the same time that object will be moving in another axis. What are you understanding? You are understanding if this object like that, this a line. What is happening over here? This particle over here, it moved how much in x-axis? 2 meter. Okay, this particle moved 2 meter. It covered 2 meter distance in x-axis. But what about in y-axis? It also moved in y-axis by covering 2 meter. Yeah, am I correct? Yeah. This side also 2 meter. This side also 2 meter. You are observing something, brother. We are observing that this particle also covered in x-axis how much distance? 2 meter. But as at the same time we are also observing that this is also going upward. It is going this side, but at the same time it is also going upward. This is what is happening. So remember, it will happen when, if this is happening, we can say yes, it is also in one axis. At the same time it is also taking another axis. That is what we are observing over here. Clear? So a object which is moving in two axes, in x-axis also, in y-axis also. Even you can take an example which is present in real life. Okay. We are crystal clear about the two dimension. In details we will explore this. Don't worry. It was just a little bit information about the two dimension, about one dimension. Now let's understand the three dimension. Remember, we will see what in this lecture our focus will be on one dimension. In separate lecture we will take a separate lecture which will be two dimension. Okay, two dimension. Some numericals will become which will be based on three dimension, but don't panic. Okay, I am telling you, don't panic. I am here with you. Now, what is the meaning of a three dimension? Three dimension. In one dimension we saw one axis. In two dimension we saw two axes. Same in three dimension we will say yes, there are three axes. That's it. That's it. So three axes in this. Let's visualize through an example. There is a particle. Okay, there is a particle. You will observe that particle is also moving this third axis. This third axis will be known as a z axis. Okay, otherwise you can see, yes, x, y, z. Yeah, I am correct. So this will be known as z axis. This is going upward. It is going this side, and this is going nothing but it is between. It is between. This is present in between of x and y. Clear? So remember, we are taking a particle. So here we can replace a particle by any object. Just to understand, we are taking a particle. So here a particle will be moving in x-axis also, in y-axis also, as well as you will observe that it is also moving in z-axis. That's why we will say that yes, this is a three dimension, because it is covering three axes: x-axis, y-axis, and z-axis. Okay. Clear? This was a little information about all this dimension. But as I told you, in this lecture, our focus will be on one dimension. Okay. Now, next topic is rest and motion. I know all of you are familiar with rest and motion. This is taught in 8th class, I think in a 9th class. Yeah. But I am assuming that yes, I want to start from scratch till the advance. We will end till the advance. Okay. So it will be very better to start from scratch so that anybody can interact with this lecture. Yeah. Okay. So tell me, what would be a definition of rest? Look, any object, any kind of object. Right? This ink, you can see this ink. It is in rest. It's not covering any kind of a distance. Yeah. So remember, any object which is not covering distance, but time is a passing. Time is a passing, but distance. This object is not covering distance. This object is not covering distance, but time is passing. It means object is in a rest. Now, motion. A object. You can consider me as an example. I am moving with a time. So, simple definition of a motion is any kind of object which is moving. If it is moving, it means it is also covering distance. Now remember, any object which is covering distance, it means that object is also taking time. Yeah. It will be possible to cover distance when time is a percent, and you know that time will be a percent. This is a forever. Okay, this is a forever. Main point is that you can take vehicle. Vehicle is a covering distance. Can we not say that yes, object is not taking time? No, this will be senseless, I would say. This is not making sense. So remember, vehicle, if a vehicle is moving, it means it is a covering distance with respect to time. Okay, with respect to time. Clear? This was the definition of motion and rest. Now let's move towards the next point. Next topic is a frame of reference. Here we will also understand about observation. Observation will be very important to understand it. Okay, observation, I am saying. So what is a frame of reference? Tell me, what is a observation? From what you are observing very clearly. It is not difficult to say that yes, we don't know. You are in 12th class, yeah. So as I told you, we will start from scratch. Let's understand first of all observation, then we will move on frame of reference. So what is observation? Look, who can observe? Tell me, who can observe? So animal or human will observe. Human will observe. So whatever we are observing, we will be observing that yes, vehicle is moving like that. Vehicle is moving in rotational motion. So here we are observing something is happening. Whatever happens, we suddenly say yes, this happened. So by observing, we say like that. Okay. Now, frame of reference. Do you know what is the relative motion, absolute motion? Are you familiar with these words? If no, okay, don't worry, it's okay. Frame of reference, it tells you with what reference are you observing any object. What I am saying, I want to know my address, okay, and in area I am new. I want to go this place, and in front of you, in front of me, you are in front of me. I asked you, where is this place? You would say something, you would tell me something. So I am asking you address, okay? I am asking you address. So how will you tell me address of, let's say, address of a college? Okay, address of a college. then you would say just go in a just cover some distance, not some distance, 4 kilometer. Okay, 400 meter, let's say 400. Then you will observe turns, two turns. So don't go in a left turn, go in a right turn. And when you will take a right turn, then in front of your eye you will observe college place. So what did you say? You took reference. What reference? Direction. Okay. Left side, this side. Cover 400 meter. Now here, in this graph, where is the reference? Tell me. Reference can be this 3, reference can be 5, reference can be 0. Yeah. Originally, if we are new, then we will say this is the origin. But as you will take tuitions, the tuition will be saying that reference point is a 4 in x-axis, 4 is a positive, then you will have to take this 4 as a reference point. And then question ask to you, if reference is 4 x-axis, then tell me after 2 unit what will be number? Then you would say 6. So you found 6 number. How? Because of reference point. A reference point is was given. This was given, which is 4. So it became possible when reference point was given by the question. That's why. So now I think you have understood frame of reference. Okay. Now let's move over here. Distance and displacement. First we will see distance, then displacement, then velocity, then acceleration. Look, I will not go into too much basic. We will cover advanced topics. This is a topic, but we will move on the advanced. So let's start from distance. From distance. At the same time, we will understand about displacement. Displacement. Clear? Because both are linked to each other. Some points will not come in this, but some points will come in this. Both are connection. This is figure about the distance and displacement. Remember, actual path. You cover actual path. A object is covering actual path. So that actual path will be distance. In other words, we can say a object which is covering total length. Okay, what are you understanding? A object which is covering total length. So total length will be distance. Total length will be distance. But when it comes to displacement, then what would you like to say? You would say, I know you are not familiar. I am assuming that you are not familiar with her displacement. So remember, so if object is covering this distance, so we will say it is how much? 21 kilometer. But what about? Okay, so this is actual path. So this total, even you can say this is total 7 kilometer. If this is total, so you can say 7 kilometer is also distance, as well as this 21 kilometer is also distance. But remember, displacement brother. This is not actual path. We will take a distance which will be in a straight, not curve. Remember, displacement will not be curve. It will be always how? I think straight. So tell me, is this a straight? Is this a straight? You would say no. So that's why we cannot say that this is a displacement. because displacement will be always shortest path or linear, you can, or you can say straight line. Clear? So we will consider this state as a displacement because it is also sorted and this is in state. That's why. Clear? Not really. Can you not say that this 7 kilometer is a distance? You can say this is also displacement. So here we are observing that the distance would be equal to displacement. Here we represent the displacement by letter S. By letter S. So this d I am considering this d as a distance. Okay. So here we wrote d is equal to S, which means distance is equal to a displacement. With example we understood this. This is also distance. It is also displacement. Okay. Observe this. D is greater or equal to S. D is greater than S or equal to S. So we have seen this, D is equal to S. But what about D is greater than displacement? That is saying that here you can see this is what distance, and it is greater than 7 kilometer. This is greater than 7 kilometer. It's not less. Yeah. So that's why we can say distance can be greater than displacement, but displacement will not be bigger. Okay, displacement will not be greater than distance. Clear? These are 3 points that you will have to keep in your mind. Okay, yeah. So let's define. Make a difference between the distance and displacement. You have understood meaning of this words. I am writing over here. This is a distance and this is a displacement. One point you have seen, one point is that the distance is the actual path and the displacement is the shortest path. Now next point. Next point is that it is a scalar quantity. This distance will be a scalar quantity. Clear? A scalar quantity. Now, why is a distance a scalar quantity? Tell me. Can you explain this? Remember, whatever quantity we are taking and we are saying that that quantity is a scalar. So reason is that that quantity is not providing direction. Okay, that quantity is not providing a proper direction. That's why we are saying that that quantity is a scalar quantity. And here distance also, it does not provide proper direction. That's why distance is called a scalar quantity. Now what about the displacement? This is nothing but just vector quantity. Vector quantity. Now what is the meaning of a vector quantity? This is a quantity. Displacement is a quantity because we can measure it. Yeah. Now remember, any kind of a quantity you are taking, if that quantity is providing a proper direction, are you understanding? If a quantity is providing proper direction, then that quantity will be known as vector quantity. Clear? Do you know about magnitude? Magnitude is a combination of a number and unit. Remember. But we are not taking direction, brother. Direction is different. So definition of magnitude is what? This is a combination of a unit and number. Yeah. So this quantity will have magnitude, but it will not have. It will not. This scalar quantity will not have direction, and this vector quantity will have both things, direction as well as magnitude. Clear? Now next point. What is the formula for calculating distance? Nothing. We will say in a discussion of first period. Okay. Next point. There are 3 points that I told you. D will be equal to. It can be equal to S. Clear? This can be equal to S, but the displacement will not be. Displacement will not be greater than a distance. Okay. This 2 point, and third point is that. Third point is you will observe that yeah, distance and both distance and displacement both are equal. Now let's move on towards the topics. I think velocity. Now one thing more. Would be okay, would be positive, but in this you will observe that this is, in this you will observe will be negative. No, not always. Would be negative, positive, or zero. Okay. Try to understand this point. Remember, distance will always be what? Positive. But displacement will be, it can be negative, sometimes it can be positive, sometimes it will be zero. It will be zero. So here we are taking negative, positive, zero, because it is providing direction. Negative, positive, zero will tell you direction of a quantity. That's why. This was also important. Next, now let's say displacement vector. Let's say displacement vector. Okay. Displacement vector. No, it's a computer. No, let's see. This is a very different topic from the previous. Whatever we understood. Let's visualize it. Uh, we have seen distance and displacement, but just we are linking this vector with a displacement, so that we can get more clarity. Uh, so read this statement. This displacement vector in terms of a position vector. To find out a position of any object, here we are taking this. We are considering this as a particle and this a also particle. Now we want to know position of this vector. So remember, this is x1. This here it will be x2, then y2, then z2. Clear? We will see what is this. Now here. So we want to know position of the particle. Another arrow. This is one. This is z axis. This is x, and this is y. Clear? So let's say this is a particle, and we want to know. You want to mark this as a position vector. And what would you do? Of course, just draw a line which should start from origin and it should till the particle. So this is origin and it is a particle. This will be known as position of this vector, of this particle. Okay, position of this particle. Clear? One more, this one. So this is a position of another particle. Okay, so you can name this A and this B. Clear? Now, displacement between these two particles. What is a displacement between these two particles? Just draw a line which is showing a displacement between them. So we are going to find this AB displacement. So how to find? And here you can see this is making a. It is giving us a triangle. That's what we are able to follow. According to triangle, we draw this triangle diagram. But according to another law, I think according to parallelogram, you will observe something else diagram over here. So according to triangle law, you are observing this triangle diagram. Okay. Now, these are position of two particles. Now, according to triangle law, we will start from here and till the another particle. Now you can see here. This particle is in three axes. It is in three axes. Can we see that this is one x-axis and this is also here. It moved y-axis. Yeah. It also moved z-axis. It also covered z-axis. Clear? Same it is happening with B particle. This moved this much distance, which is a 3, and here over here it is how much? Let's say 5. Okay, let's say 5. It moved in x-axis how much? 3 meter. It moved in y-axis upward how much? How much distance is 5 meter, and in z-axis how much? Let's say this is also 3. It is also 3. It is telling that a particle which is covered 3 meter distance in x-axis, it also went upward, which is y-axis. So it covered how much in x-axis? 5 meters, and it also covered what? Z-axis by covering 3 meters. This is what is the meaning of a vector. So our focus, our motive is to calculate this displacement. There are three axes then. So remember, according to triangle, this position vector will be considered as a R. r. Okay, this as a r. So you can say this is a radius. You can consider, but we cannot say completely yes this is a radius because there is a no triangle. That's why. Uh, Here we are considering this position vector. Uh, this position vector, which is a line which it is starting from origin till the it is ending till the particle. So this line we are considering it as a vector r1. Okay. So same here vector r2. Now, so this vector r1, this vector r1 is equal to this vector r1 will be equal to nothing but one thing more point is that this x-axis will be it is also represented as a I cap. Okay, I cap. This is y as a z cap, and this is j. Okay, this is z as a k cap. We will represent all this I cap, j cap, k cap in vector discussion. Okay, in vector discussion. And here we are talking about a displacement vector. That's why we wrote this type of symbols with letters. Now, so it's not difficult to understand this I cap. It's nothing. It is an axis, and we are naming this axis as a I cap in vector discussion. That's it. Okay. Don't panic over here. Now, so just multiply this x by I cap, this x by I cap, this y by this z by y, and this k by z. Here it gets add all this, So you will get nothing but just this. You will get this r1. Okay, vector r1 you will get. Clear? And final position vector r2. So r2 is this. It is a x2 I cap plus y2 z cap plus z2 k cap. I with hold on. X with I, y with z, and k with z with k. That is what we are doing over here. Now, remember, these are some of R2 position vector R2. And here AB is also a vector. This is also, and it is nothing but just a displacement vector. AB is a displacement, and this AB, that is what we have to calculate. So that's why here we are saying this R1, I think this R1 and R2, sum of R1 and AB is equal to R2. That is what we are saying. Yeah, that is what we are saying. So to calculate AB displacement, we will subtract this final position by initial position. What are you understanding? Final. This is a final, and this is an initial position. That is what is the formula of calculating displacement. Final minus initial. Clear? So we are considering this particle as a initial and this B as a final. So final minus this. We will get a what? AB displacement vector. Clear? So this AB displacement is equal to this much. X2 minus x1, then y2 minus y1, then z2 minus z1. Okay. So remember here we are taking x2 minus x1. So x, remember we are multiplying this x by I. Then y by z. Then z by k. Okay, that is how we will do. Same here. X2, x1. Okay, this is we are crystal clear about it. By doing like that, you will get this displacement AB. Okay, this is done. Just have a look, then I will write the next topic. Let's take some question based on topics that we have understood. Okay. Now, because uh, if you are understanding only theory, then it will be incomplete. Okay, theory plus question will be complete. This is first question. Try to understand this question. It is saying athlete completes. I think it will be name of a person. Name of a person. So there is a person which completes one round of a circular track. Circular track. We will continue with this question. Look at over it. Athlete completes one round. It completes one round of a circle track. This is a circle. Circle like that. This is a circle. It completes one circle, which track radius are in 40 seconds. In 40 seconds, how much circle? One circle. Okay, one circle. In 40 seconds, uh, he makes eight circle. One circle. So it is asking find out is a displacement where time is how this much 2 minutes and 20 seconds. 2 minutes and 20 seconds. Where one circle is equal to 40 seconds. Okay, one circle is 40 seconds. So here we have number of a circle. Number of a circle. This number of a circle. So nothing. It is nothing but now. Just convert this to 2 minutes. 2 minutes is nothing. It is 120. Okay, 120 plus 20. That is giving you 140. So this is 140 upon this 40. This 40. So we want to know what is the number of a circle where this is given and 40 second is equal to one circle. This will give you number of a circle. After cutting this, there is a number. How much? 3.5. It is giving you 3.5. So 3.5 is a circle. It is a number of a circle. How much? Three circles, then half circle. 3 circle, then half circle. Now tell me, what is the displacement from here and then it comes to rest at the same initial position. You would say displacement over here is 0. But what if it is stopping? How according to this equation, this is stopping over here. This one circle, then another circle, then third circle, then it is stopping at this because half. This is 0 point. We are taking 0.5. So 0.5 is coming over here. Now this is considered as a center of the circle. How much number of radius are you observing? Of course, this is a 2 radius. Otherwise, you can say 1 diameter. 2 radius or diameter. 2 r is equal to 1 diameter. Okay, 1 diameter. Okay. So answer is a 2r. Answer is a 2r. A person starts moving from here and in 40 seconds he makes a circle. So in 2 minutes 20 seconds wherever that person is stopping, so find the displacement between initial position and the final position. That is what question is asking, and we found what this is a displacement. 2r is nothing but it is a displacement from here to till here. But distance is a big number over here. Now this question is done. Just have a look for a few seconds. Just have a look for a few seconds. Then I will write next question. it's a complete question. Read this, then get clarity, then I will show you answer of this question. Hmm. A particle, there is a particle which starts moving from point A, from point A. This, let's say this is a point. It is a particle which is starting from this point and reaches at point B, at point B, like that, like that. Okay. Along a semicircular path. It is a what? Semicircle. This is a complete semicircular path. Find out the distance and displacement. Find out the distance and displacement. This is fixed. So this, it's a center, and this is one radius. This is another radius. So there are two radius and one diameter. This is one A, and we are considering secant point as a B. Okay. So what is the displacement of this patient and what is the distance? We know that this curve is a distance. Curve is a distance, and this AB is a displacement. AB is a displacement. So how would you calculate? We have already seen that this is nothing but 2r. So displacement over here is what? This one r and this another r. There are 2r. But what about the distance? Distance, we are talking about arc, this arc. So remember, we are in discussion of a circle. We are not talking about circle, but there is a connection of a circle chapter over here. So it is a semicircle. Now this curve is giving us a distance, and here you know that this semicircle is equal to 2 pi r. 2 pi r upon 2, because 2 pi r is a complete circle. Okay, 2 pi r is a complete circle. Remember, 2 pi and 2r. No, only 2 pi. So remember, 2 pi r is a complete circle, but here we have a semicircle. That's why we are dividing 2 pi r by 2, so that it can give us a semicircle. After simplifying this, you will get pi r. So pi r is nothing but distance from this point till this B point. Pi r is a distance from A point till the B point along this curved line. That is what is our answer. Let me write next question. It's a complete question. Try to understand this and get clarity. Then I will tell you solution of this question. Now let me solve this. When particles move from A to B point, it is a figure by this question. This is given by the question. This is one particle. This is another particle. Both it starts moving from here and it is heading over here. So then find out displacement between this AB, between this AB, where OA is a radius, OB is also radius. OB is a also radius. But according to triangle law of a vector, we will have to find the displacement. So can you write O A? O is nothing but this is a O is nothing but this is. So question is asking what is the displacement of this A to B. This is what we have to find. So O is a radius. So you can say, oh, here we are not taking vector. We are converting this vector into another thing. So this is nothing but R, and OB vector is nothing but OB vector of magnitude of OB vector is R. Clear? Clear. So AB, this AB will be equal to AB vector, magnitude of AB vector will be equal to what? This final minus initial. Final minus initial is a definition of a displacement. Clear? Final OB minus OA. Here you are crystal clear. Here just without final and minus. So displacement of this AB is equal to final position of a particle and minus initial position of a particle. Okay. So AB factor is equal to R square plus R square, because we have 2R, that's all, minus 2R square posted. And AB will come out as this much. Look at over here. This is formula of finding AB value, where it is what, nothing. So remember we took a particle which is moving in 3 axes. In that case, of course we will have to use this vector formula, which is a triangle law. So according to triangle law of vector, we wrote this formula, this formula. Okay, this formula. Yeah. We will understand how did this formula come. We will see this in separate lecture. But right now, just understand this is formula and it came according to triangle. This is according to triangle. Just to substitute value. R is how much? R is how much? Look at over here. This is giving you 2r square minus 2r into cos theta. So 2r square is a common, 1 minus cos theta, yeah, 2r square into 1 minus cos theta. Clear? This is clear? So you can take this cos theta is equal to 1 plus sine a square theta upon 2. We are substituting this value over here. So 2r square 1 minus, then we have 1 plus sine a square theta upon 2. Okay, theta upon 2. Look at it. So 1 minus 1 will become 0. 1 minus 1 will become 0. So over here we have answer 2 to the 4. This is nothing but 4r square. Then this is a sine a square theta by 2. Sine a square theta by 2. This is in a square. It is also in a square. So AB will be equal to. You can write this as AB because here we applied magnitude, that's why. So magnitude of AB vector is equal to AB. In that case, we are getting how much? This root will go to r square, square. So here a square will go because of we remove this root, that's why. So then we have sine theta upon 2. Displacement of this AB is equal to 2r sine theta by 2. Okay, sine theta by 2. This is what is a displacement of 2 points.